So let's do the pre-writing. You guys want to make all this hard. I'm not down for that. What I'm down for is come up with a plan. You may be making these way harder than they have to be. We'll see. I'm going to start at the top of this question. Block swings down, hits other block, swings back up. 3 things occurred. You agreed with me. Conservation of energy, conservation of momentum, conservation of energy. Let's pre-write. What kind of energy did I start with in this problem? All right, then I will begin with a discussion of gravitational potential energy. And when it's at the bottom, just before the collision, what kind of energies might I have there? Kinetic. I am at the lowest point then? Very likely. Any springs involved? I'm going to put V initial here. Why? There's a collision imminent. Is the collision going to change the velocity of the block? Yes, and I have evidence as to why. It doesn't swing up as high in a minute. There's ample evidence, right? All right, collision occurs. Collision's easy. Momentum before, momentum after. I did have to explain this to somebody in a different class. Momentum equals mv, right? So I'm kind of leaving that out here. I'm not putting the K for kinetic. I'm writing in what I know. You have an equation sheet. Can't get that crap wrong. Ooh. Oh, well, it's staying in. So mv initial equals, after the collision, 2 boxes stick together. Their masses join up. M plus m, v final. I think the velocity is going to change. It's going to be slower. I am not surprised by that. I am prepared for that. Conservation momentum question. After the collision, do you see that there is a clear change in height? We already established likely an energy question. What kind of energy do I have just before we start to swing upwards? 1/2 m plus m v final squared. When I swing upwards and reach a point where I'm no longer moving, for that instant, where's the energy? Wow, we're a lot quieter about that. But we changed height. Name it. Gravitational potential energy. M plus m g h final. My pre-writing is done. I've got an outline. And look, I know I'm using this stupid English analogy. It's not because it's stupid. It works. Why don't you use it here? Maybe you don't understand physics. You understand writing, perhaps. Now, I was given information. But even before I was given information, I can look at this and make some conjecture. I can do some refinement. Like, here's some refinement. Remember, take out the words you don't need. Right? Isn't that part of your refining process? Be efficient with your words. Looks like I have words I don't need. But I also have placeholders here for things I don't know. Right? That's a thing I don't know. They never gave me that. This is a thing I don't know. They never gave me that. But maybe they gave me some way to find it. For example, the first height. Is there a way for me to find it? What's that way? The length of the string. So they did give me something I could use. Seems to me I've got G times, I know how to convert from centimeters to meters. I hope you do too. Some refinement here. Do you see the refinement? I do. And actually, I'm going to work upwards on this one. 1/2 v final squared equals G times HF. They didn't give me HF. But the length of the string is the same, isn't it? And did we just a moment ago, talk about the trig on this? Oh, so we know 0.4 times 1 minus cosine 45. Making sure we're paying attention, I guess. But are we surprised by that? Like, does that surprise you? Okay, because if it does, we got a problem. Now look, when I look at this, the last piece is I do know one of the masses. I know that the one block was 5. I think I'm ready to finish my essay because it looks like I have a way to get that right away, right? A little arithmetic and I've got it. And it looks like I have a way to get that one right away. A little arithmetic and I've got it. This one wasn't the interesting one. This was the easier one if you knew L minus L cosine theta. If you didn't know that, then this one had a wrinkle in it. Pre-writing. Pre-write this question. I see a conservation of energy question. Do you see a conservation of energy question? It seems to me like the box is going to be pulled back. So 1/2 K X initial squared. I'm just going to drop the delta. Is that all right with you guys? This will launch the box. And when launched, all that energy is going to be what kind of energy? Kinetic. Speak up. Be loud. Be proud. MV initial squared. We good? Excellent. There's a collision next. Do you see that there's a collision next? I see that there's a collision next. So I'm pretty sure I can do M times V initial equals M plus M times V final. Do we know why I'm doing this, or are you just blindly copying? Because I see a lot of people just blind copying. If you're just blind copying, but you couldn't come up with that on your own, you may wish to either ask a question or write yourself a sentence or two on the side that gives you a good understanding of why Mr. Shelton decided to do that. If you did know, maybe you don't need to write that down. But I saw half a dozen papers that never once addressed momentum. Yes, sir?
It's because the block is no velocity, so you can't say right.
The original green block before the collision had no velocity, so I didn't write it down because it had no momentum for the system. I could have written M times 0 there. I chose not to. Yep. And I put the two M's in the parentheses because once they were joined together, they are like one block with a combined velocity. All good, okay? Now, after this collision, this system has an interaction with the spring. Which of our 4 things am I going to deal with now? Energy, right. I have a velocity and then I have a displacement. They're related. This seems like a conservation of energy problem. Seems like I have, to start, 1/2 M plus M V final squared, right? And that's going to equal, 1/2 K X final squared. All right. My outline is done. I've done my pre-writing. I do notice something different about this particular one than the other one. When I go in there and start refining my process, I am noticing I don't get the luxury of canceling stuff out. Do you see that yourself? So that might be a problem. That might come back on me a little bit. So, but I don't see any place where I can just cancel something out. So now let's go see if we can't go and enhance this with what we do know. Because we do know a lot of things. For example, I know that K is 500 and the original displacement was 20 centimeters, which I also know is 0.2 meters. Seems to me I know all the energy that was in the system. Any question about where any of that came from? Sure? On your test, did you do it? Because if you didn't, perhaps write yourself a note. That's going to equal 1/2. I did have the starting mass. It appears I have everything I will need to figure out the initial velocity. Do you see that? I see that. We good to go? All right. I could stop here real quick, remind myself of what I do and don't know here. I don't have to do it in the same order as before. Also noticing down here, 1/2, this might be a problem. Right? I'm plugging what I know. So for the kinetic energy, I just put in the 1 mass. That's all I know. Eight centimeters, right? 0.08 meters. All right. It looks like I can figure out the initial velocity. It doesn't look like I can figure out the final velocity. We could last time, can't this time. Are we done? Does that mean we're stopped? Because I see 2 equations and 2 unknowns. Do you? Because the moment I figure out VI and drop it in here, I will know everything in that equation except for M and V final. And I already know everything in this equation except for M and V final. That looks a lot like 2 equations and 2 unknowns. So let's move on this a little bit. What is 1/2 times 500 times 0.2 squared? I'm looking for this number right here. What's it 4? Is it 10? I've heard 4 and 10. You see why I have a problem? It's just arithmetic. It's 10. I have to believe you. But that'll be 10 times 2, which is 20, divided by 5, which is 4. So 4 equals VI squared. So VI must equal 2. I have the initial velocity. We all good? Just doing arithmetic. But that means when I use that VI, I will have 5 times 2 equals 5 plus M times VF. All righty. Good to keep going? What's 1/2 times 500 times 0.08 squared? What is that? 1.6. So 1/2 times 5 plus M VF squared equals 1.6. Just doing a little more arithmetic so I have some things down, multiplying by 2 on both sides. That seems like 3.2 now. We good? I need something here. I need to figure out an answer. I think I know what I want to do. You see, I think VF equals 10 divided by 5 plus M. I need a method. I'm gonna have to find a way to get M. So I need a method. I'm coming up with one. I want to eliminate VF. A method. We have a name for this. We're leaving the realm of arithmetic now, entering the realm of algebra 1. So sue me if my condescension is showing. So 5 plus M times 10 over 5 plus M squared equals 3.2. All righty, I did the big heavy lift in there, didn't I? I will, at least for the people in the room, do one thing. Well, I don't know who else I'm doing this for. This is going to be 10 squared over 5 plus M. One of them will cancel out. Right? Do you see why? Otherwise, either be happy with not knowing or ask. Because I'm going to assume when you don't say anything that you get it, which is the wrong assumption, clearly. Yeah?
So, did you multiply the original 5 plus M, the plugged in answer, and then when you squared the 5 plus in the bottom, you multiply the original 5 plus answer, and you cancel that one out?
What I actually did is I distribute the square, like so. And then notice I had 5 plus M in the numerator and a 5 plus M squared in the denominator. So it was here where I said cancel that, cancel one of the 2's. And that left me here. So 100 equals 5 times 3.2 plus 3.2m. Not feeling too bad about this one. Yes, I would have to agree with the person who says this one was more complicated. No, I don't feel bad, because L minus L cosine theta would be the same level of complication, in my estimation, about the way in which these problems are structured for the AP exam. And so now I go back to this, and I want to say to you guys, this was a more than fair ask. I'm not saying you understood what to do. I'm going to have to assume some of the responsibility there, because I have, in this class, 28 different answers out of 31 of you. A few of you correlated, 3 of you. But we have a problem, right? So many little things. Now,